So far in this module, we've introduced the concept of a confidence interval, and we've seen how to compute one. In this video, we will look at some issues associated with the construction and interpretation of confidence intervals. First question. So far, we've done 95% confidence intervals. What if we want some confidence level other than 95%? For example, I'm going to pull an example from a website, 538.com, that I strongly encourage you to become familiar with. Nate Silver, who runs this website, burst on the national scene in the 2016 presidential elections when he called all 50 states correctly in the presidential election. The website has a lot of political forecasts and models in it. It also has models for something truly much more important: sporting events. But in this example, I want to look at his confidence intervals for outcomes of the current U.S. Senate elections. Here's his picture. Notice he is doing an 80% confidence interval for the outcomes of the composition of the Senate after the 2020 elections. He notes that the Democrat Party, an 80% confidence interval for their number of seats, runs 47 to 55 seats. It's an 80%, not a 95% confidence interval. Now notice, we know a confidence intervals of the form best guess plus or minus some number of standard deviations. And for 95%, we know we're doing 1.96 or 2 standard deviations. But how many standard deviations do we use for an 80% confidence interval? We will, of course, draw a picture. If we want an 80% interval, then remember how Excel is set up to give us this area on down. We need to look up 90% of the curve. 80% here plus 10 more in this tail. In other words, using the norm.s.inverse function, to get an 80% confidence interval, we need to go out from the middle 1.28 standard deviations rather than 1.96. Notice what's happening here. An 80% confidence interval will give us a narrower interval. It's a narrower interval, but it's one we're less confident about. To have more confidence, we've got to cover more possibilities, but that gives us less precision, a wider interval. Well, that's all very good for you ivory tower intellectuals talking about 80% or 95% confidence. But I'm in the real world and I want a 100% confidence interval. What do we need to do to have a 100% confidence interval? That's a good question. I'm glad you asked that. To have a 100% confidence interval, we either need to survey everybody, or our interval is minus infinity to plus infinity. We are 100% confident, we would bet our lives, literally, that the true percentage of people is somewhere between minus infinity and positive infinity. You see, we've only got a sample's worth of data. We can't be 100% sure of a population value based upon simply a sample. However, we can draw reliable conclusions. We can make statements based upon the sample that can be relied upon, can be depended upon, which have a known level of accuracy. How does this work in practice, say in a Gallup poll? The text that's quoted here is from a Gallup poll press release on an election survey. And notice they're saying, based upon their entirety of their sample, with 95% confidence, they're doing 95% confidence intervals, the maximum margin of sampling error is plus or minus 3%. They went through the computations, they did the 95% confidence interval, and got a result plus or minus 0.03. But wait, there's more. Notice, in addition to sampling error, issues of question wording, practical difficulties in consulting polls, those things can introduce error or bias as well. Basically, the thing to note is that a confidence interval tells us how much sampling error we have. But you will recall from our surveys unit that there is also such a thing called non-sampling error. Error not arising from the sampling process. We have no idea how large that is in general. So in sum, a confidence interval gives us a range of values that we believe are plausible for some unknown population value. A confidence interval is an interval about which we have some confidence. Well, there are many different formulas in intro stat textbook for confidence intervals. They're always of the form of some sort of best guess based plus or minus some number of standard deviations. Keep these thoughts in mind. We will see confidence intervals again and again as we look at inferential statistics and analysis and interpretation of results from experiments.